Good morning. This is Sachin Kiske from Electrical Engineering Department, SND College of Engineering and Research Center. Today we are going to start PLC signal processing. What is exactly the PLC signal processing we discuss here? Basically, the documentation of a schematic product has a modular structure and covers the diverse topics concerning our automation system. The complete documentation for S7 1500, 8200 MP and 8200 SP. Basically, a PL system consists of the respective system manuals and function manuals and the product manuals. Let us see one by one. So, the introductory part, this chapter is basically intended to the familiarization of the essential parameter of analog input modules and analog output modules based on the fundamentals of analog technology, and the description and examples basically provided on the basic system to the manuals for respective analog modules and are intended to facilitate the handling of these manuals. So basically, analog and binary signals means exactly what. This analog and binary signal can assume only two signal states, and signal state 1 is the voltage present and the signal state 0 is no voltage present. In control engineering, it is frequently necessary to read the process and output analog signal in addition to binary signal. In contrast to the binary signal, analog signals take on any number of the value within a specific range. These possible analog variables include temperature, pressure, speed, fill levels, and pH value. Some transistors are also introduced here, that is, the controllers are only capable of processing the analog value in the form of bit pattern. For this purpose, this transistor, which can be connected to the analog module, measures the physical variables such as the pressure or temperature. The analog input module reads this analog value in the form of current, voltage, or resistor. To enable the CPU to process the current or voltage measured, an integrated analog to digital converter in the analog input module, which converts the value into a 16-bit integer value. And depending on the type of measurement, you can use the following transducer. Number 1, voltage transducer, then current transducer. It has 2-wire transducer and 4-wire transducer. The third one is the resistance transducer, that is 2, 3, and 4-wire connection transducer, and last one is the thermocouple. Additional information on wiring various types of the transducer to analog input can be found in wiring transducer. Important parameters of these analog modules are along the types and range of the measurement. The precision, resolution, and conversion time are the main points to convert when selecting an analog module, and for some applications such a system which covers a large area, common modes or channel isolation are also important. The parameters listed here are examined in more detail. Some precision and resolution values are considered. The resolution of an analog module depends on the converter and its external circuitry. An approximation of the analog signal to be acquired, the output is returned by a step curve, and the resolution determines the number of the increments of an analog value along this step curve. A higher module resolution reduces the length of increment and adds the precision to the digitization of the analog signal. Some approximation of an analog value indicates some figures which requires basically A to D and D to A conversion. So before that, let us consider the temperature or error signals. Analog to digital conversion needs a CPU process information exclusively in a digital format, and the analog value is therefore converted into a bit pattern. A conversion is done using an integrated circuit, that is ADC, in the analog and input module. For the CPU, this conversion always returns a 16-bit word for schematic product, and the ADC use digitize the analog signal and approximate its value with the step curve. Basically, this resolution and conversion speed are the most important ADC parameters. Then digital to analog conversion needs, once the CPU has processed the digital signal and integrated DAC, that is digital to analog converter in the analog output module, converts the output signal to an analog current or voltage value. The resulting value of the output signal corresponds to an output value used to control the analog actuator. Such actuator includes, for example, small servo drive or proportional value. You will find more information on writing the actuator in wiring loads or the actuator. These are some figures basically demonstrate for analog signal processing in PLC. So physical variables are generally used here, and its diagram is completely based on the signal systems or the PLC conversion system. Basically, A to D or D to A converter can be accomplished with the CPU system, and hence this PLC can communicate. Thank you.